Hi guys, I'm just wanting to give you a little bit of help in writing formulas for ionic compounds, some techniques that you can use that will help you to get the right formula every time. First of all, you need to be able to find the oxidation number for the atoms that you will be putting into the formula. Remember that oxidation numbers are based on the valence electrons and the number of electrons that each atom needs in order to become stable. We put the oxidation numbers for the A group elements right on our paper table. They are pluses and minuses, and also on the back side of that periodic table that you have a more comprehensive chart that has some of those plus some of the transition metals. Okay, so for example, some of the ones that I have on the screen here, we've got sodium, which is a +1. Remember what that means is that sodium has one lone electron in that outermost energy level, and in order for it to become stable, it's going to lose that electron. If it loses the electron, it has an abundance of positive charges, which is why it ends up with a +1 charge then. So I've got several examples on the screen. In general, the A group elements and some of the transition metals, they really only have one oxidation state, one oxidation number that you will have to worry about. But there are many, like iron, shown on the bottom of the screen, that do have variable oxidation numbers. And they're then designated by a Roman numeral. So you'll be seeing a little bit more of that later. Okay, so what you want to do first, always remember, just like we read left to right on the periodic table, in ionic compounds, we're always going to put that positive ion first. And for almost all of our ionic compounds, this is the metal ion. For sure, for the binary ionics, that is the case. When you are trying to decide how many of each atom you have, it's a pretty simple thing. You need to look back to those charges. Your overall goal is to make the charges add up to 0. So if you have equal and opposite charges and they already equal 0, you won't be doing anything. However, if they are imbalanced in any ways, you're going to have to use a method to determine the subscripts. You can do it by crisscross or you can do it by simple arithmetic. Basically, you're doing the same thing, and I'll show you that too. Okay, so again, compounds are electrically neutral, and so we have to get a 0 when we add up all the charges. And so the total number of positives plus the total number of negatives has to equal each other. If our charges on our respective cation and anions are equal, we're only going to need one of each. So the first example, sodium's a +1, chloride is a -1. One of each gets you to 0. So NaCl. Notice we don't write the ones. No ones, okay? The symbol itself stands for one atom of that element. Second example, magnesium. It's a +2. Oxide ion is a -2. +2 minus 2 is already 0, so one of each satisfies that. Aluminum is a +3. The phosphide ion is a -3. One of each satisfies the rule of balancing the charges to 0. Remember to always write that positive ion first. Okay, so here's a couple examples, and you can either write them with scratch paper or just think about them in your head as we go. But as you can see, +1, -1 for lithium and iodine. So think about how that would look. And of course, what you've got for that one is one of each. It already goes to 0. Calcium +2, oxide ion -2. One of each again. plus 3 minus 3 already equals 0. Plus 1 minus 1 plus 2 minus 2, 1 of each. So remember, I did not write any of those subscripts. Where I only need one atom of a particular element, I don't write ones. I don't crisscross the twos. I already know that my charges cancel each other. Okay, so here's crisscross. And when you are using crisscross, it's when they don't automatically equal each other. All right, so here's a great example. Magnesium plus 2, chloride minus 1, cross and drop. What that means, guys, is we cross and drop. So we take the chloride and that 1 goes over there, and the magnesium, that 2 goes over here. If that subscript is 1, we do not write it. We end up with MgCl2. When I said you're doing this mathematically, you can see how that is. Because if I have a plus 2 and I have a minus 1, I know that what I need to do is multiply that minus 1 by 2. So it's just another way of thinking about it. You're either doing it just by crisscross, but really what you're doing is you're doing a little simple math that's going to allow you to balance the charges to 0. All right, here's some more to try. You could do crisscross here again. 2 drops there, 1 drops there, leave the charges behind, CaCl2. 1 drops over behind the oxygen, 2 drops behind sodium, Na2O. No charges, no ones. Drop the 1, drop the 2, CS2S. Drop the 3, drop the 1, AlCl3. Now, one of the common mistakes I see kids make is dropping them directly down instead of crisscrossing. Make sure that if you are using crisscross, that you do the crisscross method. Okay, so there's several examples in here. If you wanted to back up the video and review the examples, you would be able to do that. One last thing to think about are these variable oxidation numbers. You're going to see a chart sort of like this, but there's a little bit more variety on the chart that you have on the back of your periodic table. But you can see that the transition metal ions are designated by a Roman numeral. But the easy part, you guys, is that the Roman numeral actually matches the charge. So if it says gold 1, that's a +1. Gold is a +1, fluorine's a -1, 1 of each. If it's gold 3, that's a +3, fluorine is a -1. I need 1 gold plus 3, and I need 3 fluorines. Okay, you're doing crisscross here. 3 goes to fluorine and 1, which isn't on the screen, but you probably remember, and you're sitting there with a periodic table probably, that's a -1. Okay, when you end up with something like this, tin 4 and oxygen, oxygen is a -2. It would take 2 oxygens to equal 4. And so we could do crisscross, but you have to be careful. If your numbers are factors, if one of them is a factor of the other, you have to reduce. This is when it's probably best just to do it by math. Okay, manganese 2 and bromine, +2, -1, crisscross, MnBr2. Things to remember. Check your oxidation numbers. You can use your periodic table and those plus and minus signs that we put at the top. You can use the chart on the back of the periodic table that you have. Easy to Google oxidation numbers. If you come across a problem that doesn't have, that you're missing a number for, you can easily look one up. Overall charges have to equal 0, and you have to make sure that you write all the subscripts correctly. We don't write the ones, and subscripts need to be below the line, and you never write plus or minus. Okay, hope that helps.